All right, so in this video we are on lesson 4. We'll skip lesson 3 just because we can't do all of the content of this course or even of this chapter. There's simply not enough time. So we'll do chapter 4, lesson 4, matching equations to graphs. Now, let's say this first example, we're just going to jump into examples, by the way. And through the examples, I'll basically just be explaining the process of how you could match a particular graph, like we have here, to one of these three equations. So let's just dive in. So one method we can use is test points. So let's do the test points method because that is what your workbook encourages you to do. And then we'll use another method, which I prefer, but really doesn't really matter. They're equivalent in that they both work. So for the test points method, basically what you're meant to be doing is taking 2 points. Let's just choose this point and that point. Looking at their coordinates. So what's the coordinates of this point? Well, here, x happens to be 0. Y happens to be, well, it's 1 unit above 5, so 6. So these are the coordinates of this point. And let's look at the coordinates of this point. We have -2 in the x values. And it's right on the x-axis, so it has no height above or below the x-axis, so its y value must be 0, right? If it has no height above or below the x-axis, or in other words, if it's right on the x-axis, then its y value is 0. So let's look at this point 0 and 6, and what we're going to do with this test point is we're simply going to rewrite the equation. Let's test this first equation. So we're going to rewrite this equation. Y equals x minus 3. Why didn't I write y here and x here? Because I'm going to substitute values in for y and x. So here, if we're testing this particular point, then this particular point has a y value of 6. So I'll plug 6 in here. And it has an x value of 0. So I'll plug 0 into the x variable, and then we'll evaluate this. When we evaluate this, we get 6 on the left-hand side equals 0 minus 3. So we get -3 on the right-hand side. And do we see an issue here? Is there an issue? Absolutely. Absolutely there's an issue. 6 is simply not equal to 3. So we know that this is not a point. Why is that? Well, let's remind ourselves what a point on a line represents. A point on a line, it's worth writing out. A point on a line represents, do you remember? It represents a solution. Right? A corresponding x and y value for some linear equation in 2 variables. So a point on a line represents a solution for some linear equation. Here, if we take this point on this line and look at its x and y value and plug them into this equation, and we find that we get a statement that isn't true, we can say 0 and 6 is not a solution for the equation that we were testing, for y equals x minus 3. Now that's a really wordy way to put it, and on a test or on an assignment, you don't necessarily need to explicitly say this. All you need to do is show that they're not equal, and that's enough for me. So because when we take this x and corresponding y value and plug them into this particular equation, we know it's not a solution. Therefore, this line can't represent all of the solutions to this particular linear equation. So this equation is done. This equation does not represent this line. They don't match, in other words. Okay, so let's look at this this next example here, and let's give ourselves some space here. What was? Oops, I just erased the constant here. What I wanted to do was give myself some room. All right, so let's move these down. Oh gosh, I'm not the greatest at technology, as you can see. So 2x, and then I'll move this down as well because I want more room so that it's not so crowded. Okay, so let's look at this equation, and let's try our same method. Let's test a point. So here we have y equals 2 times x plus 1. Now, why didn't I write y and x there? Because I'm going to substitute this value of x and this value of y into this equation, because this represents, this corresponding x and y value represent a possible solution. Do they represent a possible solution to this equation? If they do, then we have a candidate for an equation that could match this graph. Okay, so 6 equals 2 times 0 plus 1. So 2 times 0 is 0. 0 plus 1 is 1. Is 6 equal to 1? No, absolutely not. 6 is not equal to 1. Right? So all of these are not equal to each other. Therefore, 0 and 6 is not a solution for this equation, y equals 2x plus 1. So they don't match, right? So y equals 2x plus 1, if we were to graph all their solutions, it absolutely could not represent this line, right? Because we found that just one of the points doesn't even work. So it doesn't. So the main idea here, what we're doing is we are just taking a point on this line. We are plugging in their corresponding x and y values into the corresponding variables of an equation, and if we get a false statement, then we know that the equation and the graph don't match. Now, hopefully, this last equation is a contender because we already knocked out the other two. So let's try plugging in the same point here. So for this last equation, we have y equals 3 times x plus 6. Let's plug in the corresponding x and y value. So when x is 0, y is 6. It's a 0. And all right, so let's do the math here. There we go. All right, so let's do the math. Not happy with that 0. Okay, so on the left-hand side we have 6. On the right-hand side we have 3 times 0 plus 6. Hey! 6 is equal to 6. Left side equals right side. We are super stoked. We're super happy. We tested this particular point into this particular equation. We got a true statement, but we're not the happiest because it could be that this point on this line satisfies this equation, but maybe this point on the line doesn't satisfy the equation. We have to test 2 points to be completely confident that that this equation and this line truly match. So let's try another point. So we'll rewrite the equation. Y equals 3 times x plus 6. This is a long video, right? But as you get good at this, it takes a lot less time as you practice. So let's test this second point here. We tested this first point. It worked. We have some degree of confidence in this equation. But again, we need to test 2 points. And I gave it a premature check here. We are not sure if this point will work, so let's try it. Here it says when x is 0, here it says when x is -2, y then should be 0. So when x is -2, y is 0. Is this going to work? 0 is on the left-hand side. 3 times -2 is -6. Plus 6. -6 plus 6 is 0. 0 is definitely equal to 0. We had good reason to be super stoked because we tested 2 points. We tested 2 points Way to go. Super, super happy. We tested 2 points from this line, plugged them into this particular equation. We saw that each time we got a true statement. Each time we got a true statement. And so we know that this equation and this line match. So this is our answer, right? This equation matches. We have a match. Great. Okay, so that is the test points strategy, where you look for 2 points on a particular line, you plug them in, and you see if they work in the equation. Now I'm going to show you an alternative strategy with the same line. So this is going to be using the skills that we gained. Let me just rewrite this from previous lessons for analyzing slope and y-intercept of a line. So we'll get the same answer, of course, because they're both valid methods. But I find this method to be quicker, and either is useful. It doesn't really matter which one you use. Sometimes in some situation one might be easier to use than another. All right, so here is the method. I'll write it in green. Match slope and y-intercept. So if we remember, slope is the m value and the y-intercept is the b value in some equation that looks like y equals m times x plus b. So let's look at the slope of this particular line. We know how to find it, right? We can just take 2 points that clearly cross some intersection of grid lines, and we can look at how high we have to go to get to the next point. Looks like we have a rise of 3. And we can then look at how far across we can go. We'll call that the run. And the run takes us to that other point, right? We have some point A, some point B. These are clear points where they land on the intersection of grid lines. We can track how far up we have to go to get to the same height as B. We have to go 3 units up, and then we have to go 1 unit across. So that's a rise over run of 3 over 1. So you might remember that m is really just rise over run. How far up did we have to go? We had to go 3 units. How far across did we have to go? We had to go 1 unit. So we could really just simplify that as 3. So we're looking for an m value of 3, right? We're looking for a coefficient on our x term of 3. What about the b value? Well, the b value is much, much easier to find. Much quicker. The b value is the y-intercept. So when does this line cross the y-axis? Well, it crosses the x-axis here at the point A that we've noted, but that's not correct yet. That's not the y-intercept. The y-intercept is when we cross the y-axis right here. So the line crosses the y-axis right here, and that's a point we should be familiar with because we used it in our last example. And here we can see that the y-intercept is 6, so the line crosses the y-axis at a y value of 6. Or in other words, we have a b value of 6. So our b value should be 6. So what should our equation that models this line look like? Well, it should just be y equals the slope, and I'll just try to color code this. I'll write my substitutions in blue. Y equals my slope, which I found to be the rise over run of 3, times x, plus my y-intercept, which I found to be 6. My line crosses my y-axis at 6. So this is the equation that models that particular line, and which of these equations match? Well, clearly this equation matches. So here, this has a slope of 2 and a y-intercept of positive 1. Here, this has a slope of 1 and a y-intercept of negative 3. So these ones can't work, right? Only this equation could work. So that is how you can match an equation. That is how you can match an equation to the graph of a line by matching slope and y-intercept. They are both useful methods. I would say the test points example is actually, if this works for you, if matching slope and y-intercept work, that's great. But I would say sometimes you might be given equations in different forms. And if you're given an equation in a form that isn't y-intercept form, then the test points strategy would probably be better. But if you're given an equation in y-intercept form, which is this form, then matching slope and y-intercept is probably simpler. But again, I leave that choice up to you, and I will see you in the next video for the next example, where basically all we're going to be doing is matching equations to graphs.